Path Pilot Quick Tips. I'm going to talk today about torch height control and in particular torch touch off using either microswitch touch or ohmic sensing on the 1300PL. When you're cutting using a plasma jet, having the correct distance between the nozzle and the workpiece is really important. And if you're watching this, you've probably already heard about torch height control, which is essentially using the voltage coming back from the torch to change the Z height as the cut happens to allow the computer and the machine to maintain that perfect distance. So far better than you could ever do it by hand. When the torch is actively cutting, Path Pilot is sitting there maintaining that perfect distance by moving the Z-axis slightly up and down. You may have seen videos of our machine cutting through corrugated, and you'll notice that the Z-axis goes up and down as it goes past the corrugated material. That's torch height control in action, and it's something that is standard with our plasma tables. But when you first start the cut, when you're piercing, it doesn't have any voltage to know what the height should be. It has to kind of guess at what the height should be when it goes to pierce. And that's why all of our plasma routines include a touch-off. And there are two types of touch-off. Touch-off using a built-in microswitch or ohmic touch-off. And I'd like to talk to you today about the difference between those two. There's a switch inside the Z-axis, and in fact, if you lift up on this, you can hear it click, right? The Z-axis is sprung, and there's a switch in there. And the way microswitch touch-off works is it moves the torch down until the torch makes contact with the workpiece, and then the microswitch is triggered. And that's how it senses the distance from the torch to the workpiece before it pierces the material. And that's very important. Piercing is it's one of the hardest operations on your consumables, and if you don't pierce from the proper height, you're going to have reduced consumable life. But if you have a thick workpiece, your best bet by far is to use microswitch touch off. You just push it, automatically. It'll probe the Z-axis until the torch makes contact, and then it determines what that distance is. That obviously only works on reasonably thick material. So we've got some 2mm steel here, and that's plenty stiff enough. What if you had something that was much, much thinner? Just the act of pushing down on it would deform that workpiece. And that's where ohmic touch-off comes into play. So ohmic touch-off, you'll notice there's a wire that comes down to the tip of the nozzle here. And in ohmic touch-off, we actually use the fact that this is metal and it's connected to ground, and that this is metal and it's connected to the power source. And when a connection is made between those two, when you have the metal contacting the metal, you get zero resistance, and the torch senses that. So if you are using very thin material that would be deformed by microswitch touch-off, you might want to go ahead and enable ohmic touch-off. It's here on the settings screen. But here's why you want to use microswitch touch-off for the thick materials whenever possible. Ohmic touch-off relies on conductivity between the torch and the workpiece. And you might get conductivity. You notice this is a water table. You start getting water splashing up around the nozzle, and you might get conductivity when you don't necessarily want it. So ohmic touch-off can be a little bit more finicky than microswitch touch-off. And just to recap, unless you're doing something on really thin stock, you probably want to stick to microswitch touch-off, especially if you're using water in your water table. Thank you so much for watching. I hope you found this video informative.